Welcome back to another explainer. Today, we're diving straight into a foundational pillar of math, Form 1 Mathematics, Chapter 11, Introduction to Sets. Whether you're prepping for a big exam or you just kind of love seeing how math organizes the world around us, you are absolutely in the right place. Let's get into it.
So, ask yourself this. How do mathematicians easily sort the absolute chaos of the universe into logical, bite-sized groups? I mean, we do this every day, right? We separate our laundry by color, we group our phone apps by category. Well, in math, this simple act of sorting gets elevated into a super powerful structural language.
Here's our roadmap for this explainer. We're going to cover 1. What is a set? 2. Elements and empty sets. 3. Identifying equal sets. 4. Venn diagrams. 5. Complements and subsets. And finally, 6. Summary and exam tips.
All right, Section 1. What exactly is a set?
Simply put, a set is a collection of objects that share common characteristics and are classified into the same group. Think of it like a VIP club. You only get past the bouncer if you meet the specific criteria at the door. It's just a mathematical way of grouping things that have something in common.
Now there are 3 exact ways you've got to know for writing out these sets. First up is description. That's just using plain words, like saying the set of letters in the word Malaysia or the set of odd numbers less than 20. The second method is listing. This is where you actually write out the members inside curly brackets separated by commas. So for Malaysia, you literally list the unique letters M-A-L-Y-S-I. For those odd numbers, you'd list 1, 3, 5, 7, and so on, right up to 19. And finally, we have set builder notation. This one uses an X and looks like a fancy equation like X:X is a letter in the word Malaysia. Honestly, it looks advanced, but it's really just the description method wearing a mathematical tuxedo.
Moving on to Section 2, Elements, Counting, and Empty Sets. Let's look inside these groups.
Okay, so the crucial thing here is knowing this symbol. It kind of looks like a curvy letter E. This represents an element. If an object is inside your set, it's an element. For example, if our set is prime numbers less than 20, the number 5 is absolutely in that club. We write 5, the element symbol, and then the set name. But what if it doesn't fit the rule? Like the number 8, which definitely isn't a prime number. You simply strike a line right through that element symbol. That literally translates to is not an element of. Super straightforward.
Now, when they ask you to count the number of elements, usually written as n of a, watch out for this massive trap. Let's say we need to count the elements for the letters in the word wawasan. Step 1. You must always drop duplicate letters first. So, wawasan strips all the way down to just the unique letters, W, A, S, and N. Step 2. We simply count those unique items. So our total number of elements is 4. Just remember, never, ever count duplicates.
But hey, sometimes a set's condition is literally impossible to meet. What if I asked you for a set of months with 35 days? Yeah, there aren't any. That leaves us with what we call the empty set, which is exactly what it sounds like. It has its own special symbols, a circle with a slash through it, or just a pair of empty curly brackets. Oh, and a quick tip, never put that 0 with a slash inside the curly brackets. That is a super common mistake on exams.
All right, let's hit Section 3, Identifying Equal Sets. Equality in sets is all about having the exact same ingredients. Check out Set A, made up of the letters in the word harum, H-A-R-U-M. Then we have Set B, which has the letters in the word murrah, M-U-R-A-H. If you look closely, both sets contain those exact same 5 letters. It totally doesn't matter that they're scrambled up in a different order, because every single element in Set A is identical to every single element in Set B. They are perfectly equal sets. So we just write A equals B. Moving to Section 4, Visualizing with Venn diagrams. Time to draw this stuff out. Enter the Venn diagram. Named after logician John Venn, this visual code is actually incredibly simple once you grasp the 3 basic shapes. First, you've got the large rectangle. This represents literally everything you're dealing with in a given problem, the universal set. Inside that rectangle, you draw a circle to represent your specific set, like Set A or Set B. And finally, the elements themselves go inside the circle. But here's the catch. Each one must have a little dot right next to it. Seriously, no dot, no marks on the test. Rectangle for everything, circle for the group, dot for the item. Section 5, Complements and Subsets. Let's see how these groups interact. Okay, before you can figure out what's missing or what's included, you have to establish your boundaries.
That is your universal set, represented by that fancy squiggly symbol called Xi and drawn as the entire rectangle. It is the master set containing all the elements currently under discussion. If our math problem is exclusively about numbers from 1 to 10, then our universal set is strictly 1 through 10. Nothing else exists outside that rectangle for that specific problem.
Once you've got your universal set, finding the complement is a breeze. Notice that little apostrophe mark next to the A? We read that as A prime. If you're looking for the complement of set A, you're just listing every single element in your universe that is not in set A. Visually, on a Venn diagram, it's everything sitting outside of circle A, but still trapped inside that big master rectangle. Next up is the concept of subsets, which uses the sideways U symbol. Set B is a subset of set A when every single member of B is also found inside A. Think of it like a smaller group nested entirely inside a bigger group. For example, if set A is all numbers and set B is prime numbers, then B is a subset of A. Visually, you draw this as a smaller circle sitting completely inside a larger circle.
Now, I want you to lock this golden quote into your memory right now. The empty set is a subset of every set. This is basically a cheat code for your exams. If a question ever asks you to list all possible subsets of a particular group, your very first answer should always be the empty set. It is universally a subset of literally any other set you'll ever encounter.
And finally, Section 6, Summary and Exam Tips. Let's lock this knowledge in.
Honestly, mastering Chapter 11 completely relies on your fluency in this specific symbolic language. You've got the squiggly Xi for your universal set. That's your overall boundary. The slashed circle for your empty set, meaning nothing's there. The curved E for element, meaning an item belongs. The sideways U for subset, meaning a group is fully contained within another. And the prime apostrophe for complement, meaning everything outside that specific group. Take a mental screenshot of these. Knowing these 5 simples cold is going to save you massive amounts of time.
All right, here are your 3 golden exam tips to help you dodge the most common traps. Number 1, always remember to drop those duplicate elements when listing or counting for the number of elements. Like we saw earlier, Wawasan only has 4 unique letters. Number 2, subsets mean fully contained. If even one single element isn't in the parent set, it is not a subset. And number 3, always put a dot next to your elements inside the Venn diagram circles. If you just write the number 5 without a dot, the examiner might think it means there are 5 items in there, not the actual number 5 itself.
Sets aren't just rigid formulas stuck in a textbook. They're literally the logic framework for how we organize our entire digital and physical lives. Every folder on your desktop, every genre on your music app, they all follow these exact same rules. So keep looking for those universal sets and subsets all around you. Which leaves me with a final thought for you to ponder. Next time you're sorting through the chaos of your own life, maybe organizing your favorite playlists or sorting your apps, ask yourself, what are the mathematical set rules you just intuitively used? Thanks so much for joining me on this explainer, and as always, stay curious.